Hi, I am Sudhir and I am a PhD second year student here at IUCA. Our research group works in the field of gravitation wave astronomy. So, gravitation waves were predicted by Einstein in 1916 and they were detected around 100 years later in 2015 by the LIGO detectors. What are gravitation waves? So, the gravitation waves are ripples in the very fabric of the space time, as we call it, and they are emitted when, for example, so they are emitted during extremely violent astrophysical events such as two black holes orbiting around each other, after which they merge to form a single bigger black hole. So, the measurable effect these gravitation wave imprint on an object when they pass through it is that they change the physical dimensions of that object, and that is exactly how we measure it. But usually these events take place so far away that these measurable effects could be very small. But the LIGO detectors are sensitive enough that they can measure change in length as small as 1/10,000th of the size of proton. One of my key projects in which I work upon is the problem of detection of strongly lensed gravitational wave events, and we have so far not detected any of such events. So, what is strong lensing in general? In the context of electromagnetic waves, when the light emitted from a distant source such as a galaxy comes towards us, and if there is a massive galaxy or cluster of galaxies sitting in the path of those light rays, then what happens with that light is that that beam splits into multiple rays, and those rays arrive at different times towards us. So, what actually we see on Earth? So, we will see multiple images of the same in the around some patch of the sky, and they will appear at different times. It turns out that gravitational waves can be lensed too. So, what benefit we will get from the detection of strong lensing of gravitation waves? I can list few of the reasons. For example, strong lensing of gravitation waves can help us to measure cosmological distances more accurately. They can also help us see how the intervening matter between the source and us is distributed, and also these can also help us to measure how fast the universe is expanding.